isn't. Perfect. So one of these is buffer and one of these isn't. And if I add acid to both of these, what's the buffer going to do? The buffer solution, what do you expect to happen?
It's gonna go slow.
It's going to change slowly, right? And then the non-buffer solution is going to change dramatically. That's what we're going to do. So I'm going to add basically 1 drop at a time. I know your lab said 10 drops at a time, but I'm going to add 1 drop just to see how dramatic this effect can be. So hopefully you can see I'm adding 1 drop. And I added 1 drop, and I'm going to kind of stir it around. And what happened? It did not change. Okay, perfect. I'm going to add 1 drop of acid to this thing. And I'm going to kind of stir it around. And what happened? Ooh, that's not bad. It was sitting at what, 6 point something before? And it changed, after 1 drop, it's changed by over half a pH unit. That's pretty, okay, all right. So I'm going to go back here, and I'm going to add 1 drop to that. Ooh, that was 2 drops. All right, whatever. I'm going to add 1 drop. Oh, that was 2 drops. Oh, shit. Okay, all right, whatever. So I'm going to stir this around, and, okay. Has the solution on the left changed its pH?
No.
Kind of. It changed from 7.09 to 7.08. Okay? Has the solution on the right changed its pH?
Yes.
Yeah, I've added 3 drops of acid so far. Is this enough to illustrate to you the idea behind a buffer solution? Without a buffer in your blood, every time you ate an orange, I saw people eating oranges earlier today, and I thought, oh man, without that buffer in their blood, holy, they would just drop dead. You would just not instantly, but as soon as you digested the acid and things like that, you drop dead. It's amazing what the buffer does. Here, now I'm going to go pretty overkill, okay? I'm going to add a pretty large dose of acid, and hopefully it'll come up on here. Blah, there we go. And I added a pretty significant dose of acid to there. Did the pH of our solution change very much? No, by 0.2, something like that. I'm going to add the same equivalent to the other solution and stir it around. That's what eating an orange would do to your blood. That's what eating an orange would do to your blood if you did not have a buffer. So we started at about 6 point something, and now we're at 2 point something, right? I've added equivalent amounts of acid to here and here, and one didn't change very much, 1 did change a lot. Why? Why does a buffer resist changes in pH? Can somebody define for me what a buffer is? Okay, all right. What is a buffer? Jaden.
It's like the conjugate base that takes the hydrogen from the acid instead of water.
So it's a buffer is just a combination between weak acid and its conjugate with weak base, right? So you got both the weak acid version and the weak base version, right? Okay, sure, no problem. Now, if I added in here, like the buffer that we just saw, the buffer was the H2PO4 1 minus ion and the HPO4 2 minus ion. Okay, we're adding acid, so it's going to react with the stronger base. Would you agree? We're adding acid, it's going to react with the stronger base. Which one of these is a stronger base? A dihydrogen phosphate ion or a hydrogen phosphate ion? First one and the second one, which one's the stronger base? How could you tell? You just check the table, this one's the stronger base, okay? So this one's the stronger base. So what's happening is the hydrogen phosphate ion is reacting with the hydronium that we're adding, and it's turning it into dihydrogen phosphate and water. Okay? Now we've got this equilibrium system here. Now, what happens when I add more hydronium? When I add, when I add more hydronium here, which way is this going to shift? To the left or to the right? It's going to shift to the right. It's going to shift to use up that extra hydronium that we just added, right? So if we add 10 hydroniums, 9 of them will react with the hydrogen phosphate and turn into that, okay? So we added 10 of these, but really 9 of them react, so we really only added 1, okay? Did the pH change significantly? I added 10 of them, but only 1 of them remains. Did the pH change significantly? No. But did it change a little bit? Yeah, it did change a little bit. Does that kind of make sense? This buffer is going to sacrifice itself by reacting with the acid to turn into something more neutral. So that's the way a buffer works, okay? And you'll be able to spot a buffer from a mile away because the buffer has both conjugate acid and conjugate base present. So when I look at this particular graph, okay, you can take your notes out if you want. It doesn't matter to me. At the very beginning of the titration, do we have a buffer? The very, very, very beginning. What's the only thing here? Acetic acid. Okay? Then we start to titrate it, and then we have both of these things. Is this a buffer?
Yeah.
Oh, that's a buffer, and you can spot a buffer because of what's there, right? Okay. So that's a buffer region. Do you see how it's resisting changes in pH? But then what happens is we start to run out of the acetic acid. We start to run out of acetic acid, and when we run out of acetic acid, then the pH can no longer be buffered. And the pH shoots up, just skyrockets, right? At this point, what the hell is that point called?
Equivalence.
That's the equivalence point. What is the definition of an equivalence point? Equal amounts, right, of that thing and that thing. So if I add 50 of those and 50 of those, they react and they turn into 50 of those and 50 of those, right? So what's happening here is at equivalence, you've officially run out of whatever you started with. That's what equivalence means, is that you added equal amounts of this and this, so they reacted and you don't have any more. So acetic acid, we don't have any more of that. But we have acetate. Now what are we constantly adding the entire time in this titration? What are we adding here? The titration of this with
Hydroxide.
yeah, we're adding hydroxide constantly, adding more and more and more hydroxide. So at equivalence, we only have acetate, and we just keep adding hydroxide. So the pH keeps going up and up and up and up and up. Is this a buffer zone? No, because all we have is CH3COO minus and OH minus. Does that look like a buffer mixture to you? No, that's not a conjugate acid and its conjugate base. Do you know what I mean? Does that kind of... So you're always going to have a buffer zone before an equivalence point. Before an equivalence point, you will always have a buffer zone. But at the end of a titration, that's not a buffer zone. That's you diluting base into your sample, right? You're just adding base and adding base. So the pH is going to go up, but eventually it's got to stop, right? pH can't go up forever. So so let's take a look. I'm going to look at some other titration curves. How many buffer regions do you see in this particular graph? I see 2, right? I see from here to here, there's a buffer region. From here to here, there's a buffer region. Is there a buffer region here? Nah, no buffer region. Because all you have is conjugate weak acid and more hydronium. Always hydronium. Always, always, always adding hydronium. Does that kind of make sense? So you can see a buffer region because it's way less steep. It's a lot flatter than the equivalence points are. Hopefully that makes sense. So we're basically done. I've already uploaded all of these notes onto Google Classroom, so everything's there that you need. All the videos are up on YouTube, whatever. Today, I want to give you time to work on the major assignment if you're not already done. But what did I say? What document is going to be really powerful in helping you study? The checklist / review booklet, right? That's going to be super powerful in helping you study. So if you're done the major assignment, then I would suggest working on that, or you have those diploma questions, right? There's lots of stuff you could be doing today. I am free to help you out. I would love to help you out. Let me know if you have any questions. We're gonna mark the major assignment in about 40 minutes. We're gonna mark it at 11:30. Is that okay? Yeah. Okay. Question? Yeah, fire away. That would probably be a good thing. Yeah.
There's a question.
Okay, perfect. And there's a question you want help with? Okay, no problem. Sorry.